Student, this is Sivakumar, 11th standard mathematics, chapter number 7, continuation of exercise 7.1, no problem number 17. Express the following matrices as a sum of a symmetric matrix and a skew symmetric matrix. We have two subdivisions, we can do one by one. Subdivision number 1 first. Subdivision number 1. I consider the matrix as A that is equal to 4 minus 2, 3 minus 5. We can write A as half of A plus A transpose plus half of A minus A transpose. If you simplify, you will be getting A only. Because here if I take half as common, inside the brackets you will be writing A plus A transpose, A minus A transpose, correct? Plus A transpose minus A transpose get cancelled, you will be getting A plus A, that is 2A. So half of 2A that is equal to A only. So these two are same. Okay, or else half A plus half A that is equal to 1A, half A transpose minus half A transpose cancelled, right? Now I consider this one as P matrix, this one as Q matrix. Let P that is equal to half of A plus A transpose that is equal to half into A matrix here it is 4 minus 2, 3 minus 5, 4 minus 2, 3 minus 5 plus A transpose. You can directly write the first row in first column, second row in second column. That is equal to half into the corresponding elements to be added, half into 4 plus 4 minus 2 plus 3, 3 minus 2 minus 5 minus 5. That is equal to 8, 1, 1 minus 10. That is equal to half into 8, 1, 1 minus 10. That is equal to, you can multiply it by half, half into 8, half into 1, half into 1 and half into minus 10. You will be getting half into 8 that is equal to 4, half into 1 that is equal to half, half into 1 is half, and half into minus 10 that is equal to minus 5. This is the matrix P. Now I am going to find out P transpose. P transpose that is equal to P matrix and its transpose. P matrix 4 half, half minus 5 and its transpose that is equal to, write the first row in first column, second row in second column. So 4 half, half minus 5, here it is, what it is, that is equal to P. I have proved P transpose equal to P. We know that if A transpose is equal to A is a symmetric matrix. Since P transpose equals P, which implies P is a symmetric matrix. Next, I consider this matrix as Q. Let Q that is equal to half into A minus A transpose. So that is equal to half into A matrix minus transpose of A matrix. A matrix you know very well, 4 minus 2, 3 minus 5, that is given here. Here I am going to write A transpose, that is very simple. Write the first row in first column and second row in second column. that is equal to, right, half, and we have minus sign, so we can subtract that corresponding elements. 4 minus 4, minus 2 minus 3, 3 plus 2, minus into minus plus 2, minus 5, minus into minus plus 5. That is equal to half into 4 minus 4, 0, minus 2 minus 3, minus 5, 3 plus 2 plus 5, minus 5 plus 5, that is equal to 0. You just multiply it by half, half into 0, half into minus 5. You can directly write half into 0, that is 0, half into minus 5, that is minus 5 by 2, half into 5, that is plus 5 by 2, and half into 0, that is equal to 0. This is the matrix Q. Now I am going to find out Q transpose. Consider Q transpose equals, Q transpose means Q matrix and its transpose. Q matrix we have 0 minus 5 by 2, 5 by 2, 0. Transpose means we are interchanging rows and columns. Write the first row in first column and second row in second column. Okay. Now I take minus as common. If you take minus common, it will be like 0, here minus 5 by 2, here plus 5 by 2, here 0, correct? Because minus into 0, 0, minus into 5 by 2, minus into minus 5 by 2, that is plus 5 by 2, minus into 5 by 2, that is minus 5 by 2, minus into 0, 0. So I have taken minus. Now look at that matrix, 0, minus 5 by 2, 5 by 2, 0, here it is. What it is? That is equal to Q. So finally we have proved Q transpose, that is equal to minus Q. We know that if A transpose, that is equal to minus A is a skew symmetric matrix. Here we have proved Q transpose, that is equal to minus Q, which implies Q is a skew symmetric matrix. Skew symmetric matrix. Therefore A, that is equal to, look at that, equation number 1, let it be number 1. Here equation number 1 implies, here this one we consider as P, this one we consider as Q, P plus Q. A, that is equal to P plus Q. P is a symmetric matrix, Q is a skew symmetric matrix. So finally you have to write the result. Thus A can be expressed as the sum of symmetric matrix and skew symmetric matrix. Okay. Now we can go for that second subdivision. Here we have that second subdivision. I consider the matrix as A. Let A, that is equal to, the given matrix is 3, 3 minus 1, minus 2, minus 2, 1, minus 4, minus 5 and 2. Then we can write A as half of A plus A transpose plus half of A minus A transpose. Let it be number 1. Consider this expression as P. Let P, that is equal to half into A plus A transpose, that is equal to, write half as it is, into A matrix plus transpose of A matrix. A matrix, here it is a 3, 3, minus 1, minus 2, minus 2, 1, minus 4, minus 5 and 2. And its transpose, you know that, write the first row in first column, second row in second column and third row in third column. That is equal to, write half into, have to add the corresponding elements, 3 plus 3, 3 minus 2, minus 1 minus 4, minus 2 plus 3, minus 2 minus 2, 1 minus 5, minus 4 minus 1, minus 5 plus 1, 2 plus 2. That is equal to half into 6, 1, minus 5, 1, minus 4, minus 4, minus 5, minus 4 and 4. This is B. Which implies you can multiply it by half. If you multiply it by half, you can directly write half into 6, that is equal to, even without multiplying you can retain, let it be P. Now I am going to find out P transpose. P transpose equals, write half as it is, can directly write 6 minus 1 5, otherwise one more step, 6 1 minus 5 1 minus 4 minus 4 minus 5 minus 4 4, and its transpose, that is equal to, write half as it is, since we have transpose, write the first row in first column, second row in second column, third row in third column, minus 5, minus 4 and plus 4. Okay, third row in third column. Look at that, this is matrix P. Same, half, 6 1 minus 5, 1 minus 4 minus 4, minus 5 minus 4 plus 4. So that is equal to P. What I have proved, P transpose, that is equal to P, which implies P is a symmetric matrix. Now I consider this expression as Q. Let Q, that is equal to half of A minus A transpose. Let Q, that is equal to half of A minus A transpose, that is equal to half into A matrix minus A transpose matrix. A matrix, you know, that is a 3 3 minus 1, 3 3 minus 1, and second row minus 2 plus 1, minus 2 plus 1, and third row is minus 4 minus 5 2, minus 4 minus 5 2. Here we have A transpose, you can directly write the first row in first column, second row in second column, third row in third column. That is equal to, write half into, since we have minus sign, the corresponding elements to be subtracted, 3 minus 3, 3 minus into minus plus 2, that is 3 plus 2, minus 1 minus into minus plus 4, minus 1 plus 4, minus 2 minus 3, minus 2 minus 2 minus into minus plus 2, minus 2 plus 2, 1 plus 5, minus 4 plus 1, minus 5 minus 1, 2 minus 2. That is equal to half into 3 minus 3 0, 3 plus 2 5, minus 1 plus 4 is 3, minus 2 minus 3 minus 5, minus 2 plus 2 0, 1 plus 5 6, minus 4 plus 1 is minus 3, minus 5 minus 1 minus 6, 2 minus 2, that is equal to 0. Okay. Now we have Q. Now I am going to find out Q transpose. Q transpose equals, here we have half 0 5 3 minus 5 0 6 minus 3 minus 6 0 transpose, Q matrix and its transpose. Transpose only for this matrix. Okay, half write as it is. Then for transpose, write the first row in first column 0, 5, 3. Second row in second column, that is minus 5, 0, 6. Third row in third column, minus 3, minus 6, 0. I write minus half. I am taking minus as common from this matrix. That means here 0 becomes 0 only, minus 5 becomes plus 5, minus 3 becomes plus 3, plus 5 becomes minus 5, 0, that is 0 only, minus 6 becomes plus 6, 3 becomes minus 3, and 6 becomes minus 6, and 0, that is 0 only. That is equal to minus, write as it is. So what is in the left hand side? Q transpose half into 0, 5, 3, half into 0, 5, 3, here minus 5, 0, 6, minus 5, 0, 6, minus 3, minus 6, 0, minus 3, minus 6, 0. What it is? That is equal to Q. So finally we have proved Q transpose that is equal to minus Q. If Q transpose that is equal to Q symmetric, if it is minus Q, that is called skew symmetric matrix, which implies Q is a skew symmetric matrix. Skew symmetric matrix. So equation number 1 implies, equation number 1, here it is, look at that. We consider this one as P, this one we consider as Q. A that is equal to P plus Q. We have proved P as a symmetric matrix, Q as a skew symmetric matrix. Therefore, A can be expressed as the sum of symmetric and a skew symmetric matrix. Thus, the given matrix A can be, as matrix A can be expressed as the sum of symmetric matrix and skew symmetric matrix. Here also you write matrix P. So P refers matrix P only. Here, thus matrix A. That's all. So skew symmetric matrix. Over. Problem number 17 is completed. Then I'll be teaching problem number 18 in the next video. Thank you, children.